Okay guys, in this video we will learn about impedance transform. Okay, in the previous video we already derived how to get from transformer we can get our equivalent circuit. So the equivalent circuit is like this. Okay, we can see that transformer consists of two isolated circuit. This primary and this one is secondary. So their circuit is isolated. They are inductively coupled and they are not connected directly, okay, separated. So if we want to analyze in circuit analysis, it's very difficult because their circuit is separate, okay, consists of two isolated circuit, primary and secondary. So it's more easier if we can combine the primary and secondary. We combine together, so we can remove this isolated circuit. So we can use the technique we call impedance transformation theorem. We can transfer all the parameter from the secondary, we can transfer to the primary, or all the parameter in primary we can transfer to secondary. Then as the result we only have one circuit only. So in this video I'm going to show how to transfer it. Okay, first we have ZL load here. So we can bring load from primary to secondary, from secondary to primary. Okay, let's derive it. Okay, that is a simple one. Let's say this is our transformer N1, N2. This is our load ZL. This is V in, I in, I2, V2. Okay, we know that from this ZL is equal to V2 over I2. Okay, V2, this voltage divided by current. Okay, the transformation ratio, we know that the transformation ratio is E2 over E1, V2 over V1 equal to I1 over I2 equal to A. Okay, this is transformer ratio that we learned in the previous video. Okay, now from this equation we can get what is V2? V2 over V1 equal to A. So and I1 over I2 equal to A. So I2, so from this equation we can get V2. V2 equal to AV1. From this equation we can get I2 equal to I1 over A. Okay. So take this value and this value, we replace here and here. We will get ZL equal to V2 is AV1, I2 is I1 over A. So A square V1 over I1. Okay. A square I1 over V1. So ZL equal to A square V1 over I1. Okay. Okay, from this equation, we can say that the impedance at secondary, okay, this one is impedance at secondary, ZL, can be written as A2 V1 over I1. Okay, can be okay. This one is V1 over I1, V1 over I1, Z1. Okay, okay. This one is V1 over is Z1. So Z1 will be equal to Z load or Z2 equal to A square. Okay, we can say that the impedance, the primary impedance, the secondary impedance, we can return as in term of primary. So we can transform. We can transfer Z at load. We can transfer to primary. Okay, equal to ZL divided by A square. This is the ratio. Okay, this is the value of Z. Z2. Z2. Actually, this is the value of Z2. We want to transfer to Z primary, so we can return as this one. Okay, this is also known as reflected impedance. Okay, reflected impedance. So impedance from the secondary, we bring to the primary. So it will become Z1. We just divide by A square. Okay, for this case, A is turn ratio, N2 over N1. Okay, A is turn ratio, transformation ratio. Okay, the one is we want to transfer ZL. Okay, next. Sorry. Okay. Now we can transfer this one. We can transfer to primary. Okay, when we transfer to primary, we just divide by A square. Okay, this one divide by A square. Okay. When we transfer, we cannot straight away take this value because this one belongs to the secondary parameter. The secondary parameter, if we want to bring to primary parameter, we have to multiply by certain value. Okay. Alright. So next is we want to transfer R2 X2. Okay, R2. How to transfer R2? Okay, we know that the relation between number 2 is we want to transfer resistance. Okay, want to transfer the resistance. We want to transfer this one, this R2 to R1, or we want to transfer R1 to the primary to secondary. Okay, you can transfer primary to secondary or secondary to primary. Okay, we know that for the transformer, the power at the primary side is same as the power at the secondary side because transformer they just the transfer the power cannot be increased, cannot be reduced. The same power, input and output, same power. So power at primary same as power at secondary. Okay, power is equal to power at primary is I primary square R1 R primary equal to I2 square R secondary. Okay, I2 R2 I1 R1. Okay, now just rearrange it. I2 sorry I1 over I2 square R1 equal to R2. Okay, Okay, this one is I2 over I1 square is equal to A square. Okay, turn ratio square R1 equal to R2. Okay. Okay, this is transfer. We want to transfer from R2 to R1. So will be equal to A. Okay. This one is we want to transfer from secondary to primary. If we want to transfer the primary to secondary, R1 equal to R2 over A square. Okay. Sorry, R1. We look from, okay, which one is, okay, same as our, okay, same as our impedance. Z1 equal to Z2 divided by A square. Okay, R1 equal to R2 divided by A square. Okay, same value. Okay, given Z2 equal to A square V1 over Y1 Z1. Okay. Okay, this one is resistance. Now we go to inductance. Okay, for inductance, we know that the inductance, the relation between inductance and turn ratio is square of proportional. Sorry, yeah. Third one, we want to transfer reactance X. Okay, we know that the inductance is directly proportional to square of number of turns. Okay, inductance directly proportional to square of number of turn. Number of turns, so it's n number of turn. So we're taking a ratio of primary to secondary. Ratio of primary to secondary. So x1 over x2 equal to n1 square n2. Okay, that's proportional. N1 s1 n2. So we'll get this one is equal to a square. So x1 equal to s1. Sorry, this one is n1 over n2, so 1 per a square. So s1 equal to s2 over a square. Okay. This one is referred to primary. Okay. And also referred to secondary, s2 equal to a square x1. Okay. 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 Now here we have ZL, we want to transfer to primary. R2 we can transfer to primary. X2 also we can transfer to primary. So we are finished. The other parameter from secondary parameter to primary, secondary parameter we can transfer to secondary parameter. Primary, sorry, secondary to primary. Okay, how about V2? Okay, V2. Okay, this V2, we know that V2 over A, sorry, V2 over V1 equal to A. So V2 divided by A is equal to V1. Okay, this one is we want to transfer. Transfer V2 secondary, we refer transfer to primary. Again, E2 over E1 equal to A. So E2 over A equal to E1. Okay. This one is we want to transfer the generated EMF from E2. We want to transfer from E2 from secondary transfer to primary. So we'll get this equation. Okay. Now finally we will get just a summary. Okay, as a summary. If we want to transfer from primary to secondary, okay, for R, X, and Z, we have to times A square. Okay, times. Okay, for V, we have to times A. V times A. Okay, from primary to secondary. For I, we have to divide by A. Okay. Sorry. So the transform theorem, transformation formula for secondary to primary. Secondary parameter to primary parameter. If you want to transfer from primary to secondary, R, X, and Z, we have to. This one is we have to times. This one we have to divide by A square. For V, divide by A. For I, times A. Okay. This is the transformation theorem for transformer equivalent circuit. So now, okay, from this circuit, we want to bring all the parameter from the primary, we want to bring to secondary, we call as a refer to secondary. Okay, before that, this section we can remove it because the current flow in the into the magnetic core is very small compared to I1 and I2. I1 and I2 is very large compared to I0, so we just neglect it. So then the circuit will become like this. So now we can remove this section, this isolated section, we can remove it. So okay, the one is we want to bring all the parameter from primary, this parameter from primary to secondary. Okay, we refer to secondary means that we maintain the secondary value. I2 maintain, ZL, V2, all the parameter in the secondary we just maintain it. X2, R2. This one is X2. Okay, E is here. E2. E2. E1 is, so we have to transfer E1 to E2. We will transfer E1 to E2. With times A. E1 here. Okay. Same, E2 here. E1, E2 equal to AE1. So then E2 equal to AE1. Okay. Here is X1 prime. R1 prime. Okay. R1 prime is equal to R1 we refer to primary. sorry, R1 is our primary. R1 prime means that we refer to secondary. This one also S1. S1 is S primary, we refer to secondary. So this one is will be equal to which one? Okay. Okay, this one. AR1. Okay. R1 prime is equal to AR1. This one is x1 equal to a square x1. A square s1. So I1 is here equal to I1 over A. This one is AV1. So because we want to transfer from, okay, sorry, we transfer the primary current to secondary. So all the parameter in primary we have to transfer to secondary. So I1 over A, AV1, R1. Okay, this one. Okay, okay, done. This one is we want to transfer the primary, second as we refer to secondary. We transfer all the parameter primary to secondary. Sorry lah. So now refer to primary. Refer to primary means that we bring all the parameter, all the secondary parameter, we bring all the secondary parameter to primary side. So we maintain the value of primary parameter. Okay. Maintain V1, maintain I1, maintain R1, because this one is all the parameter from secondary we bring to primary. So the parameter primary maintain. X1. Okay, this one is X2 prime. Sorry, R2 prime. X2 prime. Okay, means that this one is from the primary, from the secondary we bring to primary. So ZL prime. This one is V2 prime. This one is E1. This side is E1, E2 prime. Okay. Okay. Prime is equal to X2 divided by A square. This one is equal to ZL divided by A square. R2 equal to A square. Okay. Okay, this is the final circuit. So from these two circuit we can see that there is no now we combine the secondary part and primary part, we combine together. So there is the circuit this circuit is very easy, we can use to analyze for the next analyze. We want to analyze the circuit theory or analyze the circuit. Before this isolated transformer, we have transformer here, so isolated different part, very difficult, so we have to combine it into these two type, whether either we want to combine from primary to secondary, so all the parameter from primary parameter we bring to secondary. This one is we refer to primary. Refer to primary means that all the secondary parameter we bring to secondary we bring to primary. Okay, that's all for now. Thank you very much. See you.